Vila Taguai. The residential project comprising 8 wooden houses at Vila Taguai, located 22 kilometers from the center of São Paulo, is a property development that was conceived as an innovative alternative, building new living spaces amongst the greenery of the city's suburbs. The site is placed among dense vegetation on an east-facing, 35% slope, and the implantation sought to maintain the natural terrain to the greatest extent possible. The 8 houses are elevated off the ground, creating terrace gardens. The trees were preserved and new ones will be planted, reinforcing the native flora. The road network is finished in cobblestones, maintaining soil permeability. Private areas are integrated with communal ones, a large garden, through the use of terraces and pedestrian walkways. The buildings make the most of natural sunlight and ventilation and utilize solar energy for water heating. The area surrounding the project must be preserved. Rainwater runoff is collected and directed to an existing stream. Sewage and wastewater is treated in a plant located within the condominium for subsequent use in toilets and irrigation. Wood is the best performing material as regards the 2 big issues of this century, energy and the environment. Its production requires only solar energy and, furthermore, managed forests help offset greenhouse gas emissions and generate quality jobs in rural areas, mitigating migration to large cities as well as promoting the economic development of producing regions. Using wood from sustainably managed forests in the Amazon region. With a well-thought-out methodology, this project's premise was to find innovative, low-cost, easily implemented technology. Close collaboration between the engineering and architectural sides enabled productive research into the method adopted, comprising wood panels used in the construction of walls and floor and roof slabs. The 10 cm strip modular system used for panel production enables them to come in widths of between 20 cm and 300 cm and heights varying from 100 cm to 550 cm. The reasoning behind this design is to allow the use of small, solid wood parts whilst still meeting requirements for a variety of architectural designs. The final dimensions of each panel facilitate prefabrication in the workshop, storage and transport to the site. Local labor can be quickly trained for production and assembly, in workshops and at sites, thus reducing the constrictive situation inherent with the need for skilled workers. The panel system elaborated for this project combines industrialization with flexibility, and can be applied at a variety of scales and is easily adaptable to local conditions without necessitating significant startup investment. Its use is characterized by a reduced environmental impact, extremely low rates of waste production, low labor costs, fast construction times and tighter budgetary control. The 8 houses, based around 3 different floor plans with built areas ranging from 129 to 173 square meters, available in single or 2-story variations, create multifunctional spaces in compact residences, and allowed the construction system to be tested. The units all have direct access to the living room and terrace level. The architectural design prioritized the use of natural cross ventilation, with the largest openings facing north or east, and the smaller ones facing west. This controls the insulation whilst allowing natural sunlight into the environments and creating the chimney effect. As the houses are built of wood and elevated off the ground, they have good thermal performance and avoid damp seeping up from the soil, not to mention creating a shaded terrace next to the gardens. The roof design includes an all-ultra membrane and provides wide eaves, whilst thermal insulation comes from polystyrene sheets affixed to the panels. Suitable acoustic insulation between stories. was achieved by adding a 5 cm deep cement slab to the floor panels. Sewage and wastewater is collected and treated at a subterranean plant located within the site, proportioning treated water for use in toilets and irrigation that results in water consumption being reduced by 30%. The rainwater collection system was designed to channel runoff toward the natural, existing stream. Each unit, as well as the communal areas, have joint plumbing and electrical inspection chambers that allow for future infrastructure installations and maintenance.